Welcome to Maths with EJD. In this video, we are talking about inferential statistics, and the second thing under that is estimation. So estimation, the previous video we started on which we started inferential statistics was about sampling distribution. So in this case, we're talking about estimation. And of course, if you don't want to miss any of these things, be sure to subscribe to this channel. Also, hit the notification bell so you can always get alerted when a new video is released. And don't forget to always comment, like, and share. So to estimation, okay, estimation in statistics refers to the process of inferring. We were talking about inferential statistics. So the process of inferring the value, the value mm, of a population parameter based on a sample statistic, based on a sample statistic. Okay. It allows researchers to draw conclusions about a larger group without needing to measure every individual. So with estimation, you can actually infer the value of a population just from the sample without needing to measure every individual. There are two primary types of estimation. Okay, we have point estimates. Point estimates. Okay, let me do my usual thing. You have point estimates and interval estimates. Okay, so now let's take them one after the other. Let's start with point estimates. So a point estimate, or you can say point estimation, right? A point estimate, a point estimate is a single value. It's a point. It's a single value that serves as an approximation, as an approximation, a single value that serves as an approximation of a population parameter. Population parameter. Okay. For example, if we want to estimate the average height of adult men in a city, we might take a sample of 100 men and find that their average height is 175 centimeters. So here 175 centimeters is the point estimate. Is a point estimate of the population mean height, of the population mean height. So this is a very simple way to go, right? Like you just take 100 random people, to ask them for their ages and sum up all the ages and divide by 100, and then the answer is 175 cm. So that will be a point estimate. Now let's take a proper example for this now and see what that is. So again, suppose we want to estimate, we want to estimate the average test score, the average test score of students in a school after surveying a sample of 50 students. We find that the average score is 82. Thus, the point estimate, it just looks like the previous example. Thus, the point estimate of the average test score is 82. Okay, so that's the deal about point estimates. Let's move on to the next one, which is interval estimates. Okay, so an interval estimate provides a range of values within which the population parameter is expected to lie along with a specified level of confidence. Okay, this is often expressed as a confidence interval. For instance, the confidence interval okay, rather, for instance, if the confidence interval for the mean height of adult men in the city is calculated. I mean, that's referring to the example we talked about before, where we said the point estimate was 175 cm. So, for instance, if the confidence interval for the mean height of adult men in the city is calculated to be 172 cm to 178 cm, we can say we can say we are we are we can say we are 95% confident that the true the true mean height falls within this range. Okay. That's the point estimate. So this way, you have a wider range within which the age can fall. So there's a higher probability. I mean, 95% confidence interval means that if you take the possibility that the height, so someone's height will not fall between 172 and 178 is actually 5%. That means that if you take 100 people, 95 of them, their age will fall within that particular interval. That's the idea of confidence interval. Again, let's do an example like before, okay? So continuing with the with the test score example, let's say we calculate a 95% 95% confidence interval for the average test score based on our sample. If the interval is found to be 78, 86, this is an open interval. So the test score lies between 78 and 86. So we can conclude that we are 95% confident that the true average test score of all students in the school lies between 78 and 86. Okay. All right. So let's talk about something else, and that is confidence intervals. Confidence intervals for means and proportions. So we can have confidence intervals for means and proportions. All right. So start with confidence interval for means. Confidence intervals for means. All right. So when estimating the mean of a population, a confidence interval can be calculated using the sample mean and standard deviation. Okay. The formula for a confidence interval for the population mean mu is given by confidence interval interval is equal to x bar. That is the, okay, of course, we are going to explain all that. X bar plus or minus z into s over square root of n. Okay, so we have that. So where first of all, x bar is the sample mean. So if you take a sample and find the mean, that is your x bar. That is the sample mean. Okay. Next, you have z. Z is the z score corresponding, the z score corresponding to the desired confidence level. The desired confidence level. It can be, for example, 1.96 for 95% confidence. 95% confidence. Then it can also be S. Oh, sorry, S rather. S in this formula, is S is the sample standard deviation, better known as standard error. Okay. And of course, N is the sample size. N is the sample size. So you get the mean, you get the sample, you get the Z, right? You get the Z score. And of course, to convert to Z score, I think I explained it somewhere, but we may have to talk about that again along the line, okay? So N is the sample size. So let's take an example. So if a sample of 30 students has an average score of 85 with a standard deviation of 10, we can calculate a 95% confidence interval for the mean score as follows. Okay, so we say that the confidence interval is equal to x bar plus z score into the sample standard error, sample standard deviation, which is standard error, over square root of n. Okay, so here, x bar, if a sample of 30 students has an average score of 85, so this is our x bar right here. Okay, with a sample standard deviation, so this is our small s. So sample n, so this is our n right here. Okay, all right. This is, so n equals this. So we have x bar is 85. Z score, 95% confidence is 1.96. Then S is 10 and N is 30 from the information we have. So we can say that our confidence interval is actually 85 plus, so this is plus or minus 1.96 into 10 divided by square root of 30. So if you evaluate all this, this is the same as So the confidence interval is 85, or better still, let's say approximation. It's so the confidence interval is approximately 85 plus or minus. So if you evaluate all this, you get 3.58. Okay. So that this gives us a confidence interval of approximately 81.42 to 88.58. So this way now, what we are simply saying is that um you can say with a confidence of 95% that the score of any student you take will lie between 81.42 and 88.58. So that's how that goes. So that takes us to the other aspect, which is confidence intervals for proportions. Confidence intervals. We talked about confidence intervals for means and confidence intervals for proportions. Intervals confidence intervals for proportions. Okay. So when estimating a population proportion, the population proportion P, the confidence interval can be calculated using the sample proportion. The whole idea of estimation is using the sample to infer using a sample statistic to infer the population parameter. That's the whole essence of estimation. So the confidence interval can be calculated using the sample proportion, P hat, with the formula. So the formula for that will be confidence interval is equal to P cap plus Z square root of P cap into 1 minus P cap all over N. So that is what the confidence interval is for proportion. Okay. So let's take an example. Okay, of course, here we already know that P cap is the sample proportion. So let me do this. This is sample proportion. That is what P cap is. Of course, and we know Z, this is the Z score, depending on the confidence interval. And N is the sample size. Okay. Clear. All right. So let's take an example. Okay, we're still here. Example. Imagine a survey where 120 out of 400 respondents indicate they prefer product A over product B. Okay, so the sample proportion P cap would be P cap equals 120 over 400, which is 0.3. pretty much. Okay. 0 cancel 0. 12 over 40. 4 goes in 12 three times. 4 goes in 40 10 times. So that's 0.3. Sure. So now if we want to calculate a 95% confidence interval, calculate a 95% confidence interval. So we have confidence interval. Okay, let me color code here. So we have confidence interval equals p cap plus or minus z square root of p cap into 1 minus p cap all over n. Okay, we know p cap is 0.3. Then z, of course, 95% for z is 1.96. Then n is the sample size, which is 400 in this case. Okay, this is n. So that's 400. Okay, so we can now say that the confidence interval now can be p cap, that's 0.3 plus or minus 1.96 square root of 0.30, 0.3 into 1 minus 0.3 all over 400. Of course, you can tidy that up a bit more. So you have 0.3 plus 1.96 multiplied by 0.3 times 0.7. That's 1 minus 0.3 divided by 400. So see, the confidence interval is approximately 0.3 plus or minus. When you evaluate all this, it gives you something like 0.048, 0.048. And we can now say, thus, the confidence interval for the proportion of people preferring product A would be approximately 0.252 to 0.348. So, I mean, if you want to do confidence interval for people who prefer B also, all you just need to do is just say 400 minus 120. That's like 280. So the new proportion will be 280 over 400, and then you can do the same thing for product B. That's something you can try out. So it's exactly the same thing. Yeah. So can we summarize? Let's summarize this as we bring all this to a close. In summary, estimation is a fundamental concept in statistics. Okay, that allows for the approximation of population parameters. Based on sample data. So you are using sample to infer the value for population. So that goes. Then another thing is that point estimates provide a single value for the parameter, while interval estimates give a range providing a level of confidence. Providing a level of confidence about the parameters location. About the parameters location. Okay, so another point is that confidence intervals for means and proportions, for means and proportions are essential, the essential tools in statistical analysis. Allowing researchers to make informed decisions and inferences based on sample data. Okay, based on sample data. So that brings us to the end of this video on estimation, which is the second video on inferential statistics following sampling distributions. After now, we're talking about hypothesis testing. We'll give an overview of hypothesis testing. Then we'll go ahead and make other videos on specific types of hypothesis testing, talking about parametric tests and non-parametric tests. So till then, stand by and watch out for those videos. Be sure to subscribe to this channel and also make sure you hit the notification bell so you can always get alerted each time a new video is released. And of course, comment. Tell me if you want to teach a particular topic or treat or solve a particular question. And don't forget to like and share so that more and more people can get to see these videos and learn a lot. Bye.